Hey folks, Dan from D&N Custom Creations. It's been a long time since I made a video. I have been looking at shop stools from Viper Industries and I've been really lusting after them. They're really sweet. The problem is the ones that I would like, they get almost 700 bucks for. I think it's like 695 bucks. You might be able to get a discount, but that's what it says on their online. Let me show you a little picture of what those things look like. So here's a picture of the one that I'm interested in, the ones that are a little bit taller. And you can see here, if I can get back out of this thing. So here's on their website a picture basically of the ones, the style that I'm interested in, the ones that are taller. And let's see if this, there's the price, 625. So not 700, but 625 bucks. And I mean, they're really nice. They're American made. I'm sure they certainly look like they're very high quality. Problem is, I just can't get myself convinced to spend 625 bucks. And so I thought, with all the equipment I've got, plasma cutters and mill and lathe and that kind of thing, is there a way that I can make this thing myself reasonably close for less than that, so I'm not having to bite that big bullet? Now, look, Viper makes a great product. I'm not saying that they don't. I just can't convince myself to spend that kind of money. If I had that money, I definitely would, because they look like a sweet deal. Anyway, so I thought, can I, with all the equipment I've got, can I make one cheaper? And so what this video is going to be is my attempt to do that, and I'll basically let you know what it cost me. So the first attempt, or first thing I did, was to go in Fusion 360 and design some legs and get them nested up so I could get them cut out on the plasma cutter. These are 3/16 steel, and I get steel from a supplier that's about 70 miles from me called Sandusky Steel. And in their cut piles, I can usually find sheets of material, maybe they're odd sizes, but for 60 cents a pound. So this material, that's about a 20 by 20 cut sheet right there, would fit those 5 legs. And I think that winds up being like 25 pounds by the time you calculate it out. So at 60 cents a pound, that's less than 20 bucks. If I were to charge a customer for these, the formula I use by the time I get my material and have to include the cost of going and getting it, the travel and the storage and that kind of thing. Plus in my little calculation, there's a cost for each pierce, small charge, and then for the path length of the cut is a charge just to kind of cover what the consumables are. Anyway, so by the time I would have these cut out for a customer, if they asked for this, it would wind up being about 70 bucks. And so my cost, probably 20 bucks, not counting my labor, so that's 20 bucks in material cost, if you add the labor, and that's what really adds up into the cost of the customer, etc. But my cost would be about 20 bucks, customer's cost would be about 75. So in my calculations here to figure out what this thing cost me, I'll kind of lay it out at the end so you can break it down so you can see what the charges were. But I believe I can make this entire stool for about 140 bucks. Now, it doesn't have the nice backrest like the Viper does, but you'll see in the end that I think it's pretty usable. Okay, I'm getting ready to cut out the 7 gauge, get these 5 legs cut out. It's a 7 gauge steel using a Hypertherm 45, and I will be using not a fine cut tip, but a regular cut tip. So let's see how this is going to cut. bad. So when we get these out of here cleaned up, we'll start the next step. Now, a big part of what makes this thing cost effective is I've gone to Harbor Freight and I've bought one of these roller seats. If you get them on sale and you can get a discount, like a 20% coupon or whatever, I got this for 25 bucks. And I'm going to use the wheels, the hydraulic rod, the seat, the rod lift mechanism, etc. For a lot of what I'm going to do. So right away, I've got a lot of bits and pieces for this thing that are, you know, for 27 bucks. Now, when I look at the Viper, they're using much larger wheels, which obviously helps you when you're running over a little crap in your shop, you know, so it doesn't bind up as much. I think they're using 3, maybe even 4-inch diameter wheels, where these are just, I think 2.5. Anyway, but you'll see what that is. Now, I've got to get rid of this base plate, but I want to keep the part that holds this hydraulic cylinder, and I'll show you this step by step. So I pulled this thing out of the box. This is what it comes looking like. And there's the seat. We'll use every bit of that seat. Now again, it doesn't have a backrest. You can probably make a piece of material that would come out and turn up and put a pad on the back. But for this video, it's not going to have a backrest. So again, I will use the wheels. But the one thing, and I don't need this plate, but I do need this piece right here because that's what the hydraulic cylinder is going to sit into. Let me show you what that looks like. So this little centerpiece is a tapered ring, basically, and that hydraulic lift mechanism just sits in there. It's not tacked, it's not welded, it's just sitting in there from friction. So I need to remove that piece. I don't want to have to machine one. Obviously I could cut one out on a lathe with the right taper and so forth, but I'm just going to go ahead and use it. I'm going to take that center part out, and you will see how I've attached that to another piece of pipe that the legs are going to be welded to, and how I incorporate that in the design. Okay, at Sandusky, I asked them to cut me about a 4-foot piece of 2-inch Schedule 40 pipe, and so you see that's what this is. Now you could probably, I don't know whether Lowe's or Home Depot or whatever, you can get a 2-inch galvanized pipe. I didn't want to screw with having to get that galvanized out of the way, so I just went with their steel pipe that they got, and it was reasonably cheap. Can't remember what it was, but and you can see, you know, how that pipe is basically you're really talking about the ID. So you ask for a 2-inch ID steel pipe, Schedule 40, and all I've done now is cut a piece off. I think it was 6 inches that I cut a piece off, and I'll show you here in a minute that I machined that to accept those little tabs in the legs. Okay, so here are the legs that have been cut out now on the plasma cutter and cleaned up a little bit. And these tabs that I've machined, or actually included in this, they're, I don't know if you can see that, about a little more than 1/2 inch width. And so I'm going to try and cut in that pipe now that I've cut to see if I can't make little holes or adaptations for those. And I'll show you how that's set up. Okay, so here's the setup. I've got that piece mounted in, it's called a super spacer. It just allows you to rotate accurately different rotational angles. And since these are 5 legs, then I actually need slots cut for those at 5 evenly spaced and positions around that. And you know, 360 degrees divided by 5 is 72 degrees. So there's a scale up here, and I've cut one. I've now moved it 72 degrees and get ready to cut the other one. And obviously the distance and the length of each of those are matched up to what I need for those legs. I'm using a 1/4 inch end mill, and I'll just show you a little bit of a cut. All right, I'll move that now to, the first one was a 72, and we'll add 72, so that's 144, and get set up to cut the next one. So just continue to do that. I'll continue to do that until I've got all the slots cut around the outside of that, and then we'll show you how we then mount the legs to it. I'll be right back. So we'll just get working on that, cutting away the welds until I can knock that out. Okay, we got it knocked out of there. Just had to cut away some of the welds. It's kind of a little bit of a pain, but you don't need this piece anymore. That place would not be used. And this part here, let's see if I can, yep, okay, you're on the camera, will be welded to this piece. And so the hydraulic cylinder will then basically go up through that. Okay. So I'll get ready to clean this up, and next step we'll probably weld the legs. Well, actually no, I'll probably weld this onto the end of that first, make sure it's concentric, and then we'll weld the legs on. Okay, we've got our tapered ring welded on. I didn't just basically did a hand job instead of putting on my rotor positioner, but it's now ready to seat our hydraulic system, and the next thing to do is to weld the legs on. So the reason obviously for the holes in the slots is to kind of help you line it up. Now obviously you can get this off a number of degrees, and if I was going to basically mass produce these things or make more than 5 or 10 of them, I'd probably build a little jig down here to hold the legs in the exact correct position, because it doesn't take much to be off a number of degrees. But I'm not going to do that. I'm just going to basically do it by hand and try and eyeball it, and we'll see how it goes. Okay, so got the legs welded up. Put some gloves on because it's hot. And while they may not be exactly in 72 degrees, it's not a problem. Just take a hammer and bend these. As we get to the point where we're putting the footrest around, we'll make sure that these are evenly spaced, and that'll help make sure that it's nice and level. Anyway, that is the next step. So let's see if we can bring you in a little bit. You can see they're just some small welds along each of those legs. Didn't do full welds. Don't think you need to do it. We'll find out in the next step what the next process is. All right, next thing we're going to do is get some 1x1 by 1/8 inch angle, and we're going to cut 5 pieces a little more than 1 inch. So you see I've set up a little bit of a fence here. I've already cut one. Okay, so what these are actually going to be used for is these are going to be used for mounting the wheels. So they'll be welded onto the legs after we drill a hole for the wheel to go through. Now, if you notice here, let's see if I can show it and bring you in a little closer. If you notice, these are got the square base to them, so when you put them in, you don't have to put a wrench on the other side. And that it measures about 0.39 inches. So there's 2 options. Number one, I can cut a hole that's exactly the same size as the flats, about 0.3, and then try and square up this with a file, which is kind of a pain, obviously. But if you're anal, go ahead and do it. The other option is to go ahead and cut a hole that's just slightly less than 0.39, and allow this, when you pull this up into the hole, it will hold it in place well enough that you can crank down on the nuts. Since you're not taking these things on and off, that's the way I'm going to do it. So I'll show you how I get that set up. So if I want to drill a hole that's just slightly smaller than that 0.39, I'm over here on my drill index chart for a drill set, and I'm just going down through and looking here, and there's W drills about 3.86, V 3.77. I might try the W and see if that works. Now the option is to come down here. I think 25/64 is here it is, 3.906. So that's pretty close too. So I think either one of those would work. I want to go a little smaller than that 3.9, so I think I'll go with my W drill and see if that doesn't work. I'll spot drill that. I'll probably punch through with maybe an 1/8 inch or even like a 1/4 inch, and then I'll finish that out with that W drill. All right, I'll hold on. Okay, I'm using an 1/8 inch drill, get a pilot's hole started, and I'm not trying to be super accurate. I'm just trying to make sure that I'm somewhere close to the middle of that thing. And that's basically it. Do that to all of them. All right, we're going to swap that out for our W drill. slow this thing down a little bit. Let's see what I'm going to use. I'm going to call this mild steel. Okay, here's one. I haven't deburred or anything. I'm not going to bother. But let's just see if our W drill did the trick. All right, I think we're good. I'm not sure you can see. Pulled it right up to the bottom. So that will work. Now we'll show you what it looks like when we get them put on the item, the stool. Those babies will be stuck on. Let's see if you see that. They'll just be welded on, and so the angle will be welded on. Obviously, I'll take the wheels off first, but I will weld those on, and the position of those, if I can find another one, if you find that you like this is not level, and you can adjust using just this. So wherever you weld this will allow you to make sure that your entire stool is level. Okay, so once we've welded those small pieces of angle on each of these legs, then it's just a matter of mounting the wheels on. So let's do that. We'll put some gloves on here. It's a little bit warm yet. And these are the wheels that came off of the original Harbor Freight little stool. So here is, if you prefer, larger wheels, obviously you could do that. Now,
I'll put the rest of these on there and bring it back.
all right, got all the wheels on. We're just about done. I mean, this is, there's not a whole lot to it. So now that we've got on the bottom, we've got the tapered part welded to the tube. We've got all our legs on, welded around. We've got our wheels put on. Then here's the cylinder that comes in that Harbor Freight kit. Basically just drops in. The seat has also got a little taper to it that fits over top of the shaft. So that is it. Now we've still got to put the footrest around the bottom, and so we're gonna have to fabricate that. But basically here is the seat, and it's got automatic height adjustment, and I like it. Pretty slick for that amount of money. Okay, so the next thing we'll do is we'll try and fabricate that circle that goes around the bottom of your footrest. And there's really two options. Let me put this back on the table and I'll show you. Okay, for the footrest, I think there's really two options. Obviously the slick part, and the way that that Viper is, it's a ring that goes all the way around and obviously secures each of the legs and keeps them from being able to flex. But you have to have a way of rolling that ring. I've got a roller. I'm going to actually attempt it. I'll probably use EMT conduit and see if I can get that rolled up into a circle that size. The other option is just go ahead and cut some tubing, or so maybe it could be square tubing, could be round tubing, whatever, and piece them in at each of the locations and weld them at each of the locations. Now what that does is, the round part will stick out a little bit, whereas if you just cut them straight across with something, you might have a little trouble getting your heel onto it or whatever. If I have trouble rolling that thing into the size that I want, I'll probably just go ahead and piece those in. Even if I had to roll it, if it couldn't make it round, but I could put it into sections in rolls, that still would accomplish the same purpose. So that's what I'm going to attempt next. I'll show you how I attempt it and whether or not we're successful or not. Okay, I'm attempting to make this loop. You can see I've already done a little bit. I wasn't sure it was going to even be possible, but I'll keep trying here and seeing if we can't make this thing Not sure what to do about this, how to get that to go through there. I've never tried to actually make a loop like this. I've used this to bend some various pipe and so forth, but I have never made a loop like this. So I don't know if I try and get that on the outside, maybe. I've kind of calculated this to need to be about 24 inches in diameter. Let's see what that is. Let me grab my tape measure real quick and see if we're anywhere close. Yeah, it needs to be a little tighter than that. So I will just keep working it. You can see what I'm trying to do. And whether or not I'll be successful in making it round, I'll bring you back. Well, now that I've got it in sort of the right size, next challenge is how the heck to get the daggum thing off. Like I say, I've never made a ring like this. I tried a tubing cutter, but as you would expect in the process of rolling this thing, because the die isn't exactly the diameter of the tubing, well, then it flattens it out. So that doesn't work very well. So I'm just going to have to brute force it, try and cut it off. And as expected, it traps the blade because it's, let's see if I can. I'll clean that up once I get it off. All right, let's see if that'll come off now. Hey. All right, now we got to see if I can make that 24 inches and at least somewhat resembling a circle. I'll bring you back. All right, here's the end result of my attempt. Far from perfect. You could see that, especially right here, I got some issues, and I could spend some time trying to make that a little straighter. What I may do is actually just kind of hide it at a joint. Won't look so bad. But the rest of it, I think I can attach some brackets that then I can weld to this thing, and it's probably going to be just fine. And in hindsight, it certainly would have been easier just to go straight across, but you can see the putting your foot here versus putting it straight, you know, across would be a little bit different. So I'm going to try and figure out how I'm going to attach the little brackets to this. That's pretty thin. I need to get rid of that galvanize on the outside, and we'll get it tacked up, see what it looks like. Okay, here's the end result. Basically made some brackets that had a half U in it, and welded it to the conduit, and then welded it again to the legs. Where the two legs come together, let's see, they're right here. Not pretty, and but they're going to hold. I wanted to mention, after I took the pipe, when I was trying to make it round off of the, you saw the device over there I was using, a little bender. After I did that, I used this conduit bender to kind of help get it in the right direction. Could I have done the whole thing with the conduit bender? Probably. What I would more likely done is marked off maybe every inch and then just gone around and tweaked it. I'd probably calculate how much the bend would have to be at each of those in order to come up with the circle. But the little bender over there seemed to work okay. Let me put this thing on the ground. And get you over there looking at it. And that is the finished product. Now, I'll probably powder coat it. You wouldn't need to. Inside the shop here, it stays pretty dry. But so it's got about a 6-inch height change, and I'll be using this for welding. So more than likely it'll be pretty close. I don't know if you can see that in the picture or not. Yeah, so I'll be using it probably for like TIG welding. I probably won't use it for MIG welding, but for TIG welding, where I can get down here and get some little close detail. But it also has got the ability to go up to a little bit higher if I need to, if I have my welding position or something like that. So anyway, I'm satisfied with it. Is it Viper quality? No, absolutely not. Is it functional? Darn yeah. So I will put together a little spreadsheet just so you know what I've spent, and give you an idea of what it would cost. Obviously, you guys are going to build one of these things. Most of the people who watch my channel watch it because of the plasma table, maybe a little bit of machining, but mostly the plasma table. And so you can cut out the legs. I think the piece of pipe is you can do that by hand, grinders, cut-off wheels, etc. What you would probably have trouble with is cutting those slots for the tabs in the legs. You wouldn't have to use those. You could build yourself a little jig, even wood, to kind of hold the legs in the right position. Just grind those tabs off and just weld it straight alongside the pipe. With cut-off wheel stuff, you can take the piece out of the Harbor Freight base, and that's really it. You wouldn't have any trouble building one of these things. So I'll put together a spreadsheet so you know what I spent, and maybe if you want to do one yourself, I'd love to see it after you're done. I'm sure you do a better job than I did. I pretty well whacked it out, but hey, it's functional. All right. Thanks, guys. Dan from D&N Custom Creations. See you.